Dude, we need to get a Jaws themes for like whenever Daniel shows up. Just like dunk 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 dunk. Like so I can just click it every time I see Daniel show up. Then here goes Daniel. Just
All right.
pray. But
I'll put one
I'll
on
let
there.
you. There you
I'll
go.
put one on there. It ain't hard to do.
Every
All right.
every time Daniel shows up, we'll key it up.
All right. Okay. Now, before we get started on the commercial calculations, what I'm going to do is I'm going to go through and show you. When we did the residential calculations, we had 6 loads we had to do. Okay.
Right.
So we did the general lighting and receptacle, small appliance and laundry load. Then we did the cooking equipment loads. We did the dryer loads. And then we had your heating and AC load. All of those, once those were calculated, everything else that was left went in the fixed appliance load. And then the last
Sure.
load was the largest motor. Now, when you do 2023, which we'll do another series of this, I'll go over that. But you'll have your EVSE load that'll be calculated separate, and I'll show y'all how to do that. Now, when
Gotcha.
you get here to commercial, you'll end up doing the same thing. We'll end up adding another load, but for 2020, we're going to do 7 loads. Okay. And as we go through these 7 loads, you'll see that it's really not that hard to follow. What we're going to do first is we're going to do the lighting loads, and we'll do general lighting load. We'll do show windows, lighting track, low voltage, your outside lighting loads, and you also have your outside lighting loads. And then after we get through there, then we'll look over at table 220.42 and look at the lighting demand factors. So that's one full load that we'll do. Then the second load we'll do is receptacle loads. And we'll go in and look at our general purpose receptacle loads. We'll do it for non-continuous. And then we'll have our general purpose receptacle loads if they're continuous duty. And then you got your multi-outlet assembly loads, which are used simultaneously or non-simultaneously. Then my
Right.
third load will be special loads. These will be special appliance loads. So there's 3 things we'll look at. The first one is just your regular special appliance loads that are used continuous or non-continuous. Then your next one will be where you get in and you deal with your kitchen appliance loads. And then we'll look at applying the demand factors with that. Okay.
Okay.
Then my fourth load is compressor loads. And we'll look at refrigeration and cooling. Basically, just like we did for residential, we'll be looking at non-coincident loads and dropping the smallest of the 2.
Okay.
Then we'll look at motor loads. We'll do my single phase and 3-phase loads. And then we get into the last one, which is we're going to deal with is our largest motor loads. Okay. So all this is going to seem very, very simple to follow. We're just going to break it down and do it step by step. Now, after I finish this, next week there will be exercise problems to go through, calculate all of these. Then we're going to
Okay.
finish that next week, and then the next week after that, I'm going to come back and I'm going to do the full calculation. So we're going to try to wrap all this up, and after this week in 2 more weeks, and that would have been a full calculation presentation for your journeyman and master prep.
Hey,
That,
just noticed a couple people popped in over Facebook, so I just appreciate you guys joining us.
thanks,
So
guys.
I posted that over on Facebook, so you guys can see it over there. Appreciate it.
Yeah, it's sort of funny because I was looking, and we over on the Rumble channel. Thank y'all for joining. We had 7 viewers going on full time over there right now.
Nice.
So
Well,
pretty good.
shout out to the old Rumbly.
Yep.
There's not many people that get that many views over there, so
Well,
awesome.
we're building it up.
Nice.
All right, now let's look at some basic loads here. So they could be asking you on the lighting load, and I'm just going to give you some loads here. We're going to tell you if you have a non-continuous load of 60 amps and a continuous load of 100 amps, how do you calculate it? It's no different than like doing a branch circuit. Now, what I want to point out, and y'all have heard me say this many, many times, I said, if you go over and look at 210.9A10, that's the base circuit. 215.2A10, that's your feeder circuits, and 230.42A1, that's your service. Okay. The thing is, anytime you're doing a non-continuous load, you take it at what? 100%.
100%.
Continuous load, 125. Doesn't matter
Yep.
which one of them you're doing. You're still going to do it the same for the branch circuit, feeder, or service. Okay. So,
So, question for you, like, so that's in commercial, right?
mm-hmm, or
Would
industrial.
so is like I think this is kind of interesting because I know in commercial there are 100% rated breakers.
Sure, there are.
So, basically, is that load based on an 80% breaker?
Well, this is because we're doing a
Right.
service.
Oh,
I'm not
gotcha.
doing a branch
Gotcha.
circuit. All I'm doing here is just we're doing a full prep for a service calculation. I'm just telling
Nice.
you this is how you go about calculating.
Gotcha.
Okay.
Because I know they do the continuous load based on the breaker only being tested in open air, and then once you put it in that closure, then you have to add that 25% for the
Sure.
heat
And
dissipation.
for the newbies, he's talking about the 80%. What it used to be, you would go over and look in 384-16D, and it'd tell you couldn't load the breaker more than 80%. So
Right.
what would happen? People would do the calculation, then put 80% on it, and then the breaker would be too small after you've added the 125%. Well, you've
Right.
already done that 125%. So let me give you an example. If I took 20 amps at 80%, that gives me 16 amps. If I took 16 times 125%, that gives me what? 20 amps. Okay.
Right.
So the 125% is already taking care of the 80%. So if somebody
Gotcha.
comes up and tells you that, that's what it was based on. And they got rid of that 80% because it was being misapplied. So
Gotcha.
they took that out of the code. All
Okay.
right.
All right.
So,
Sorry for interrupting.
oh, no, hell, it doesn't bother me. Ask any questions, huh? That's what I'm
Yeah.
here for.
I just like it because I hear all this stuff and like big shout out to all the people that follow the show. They always come up to me at work and ask me all kinds of questions, and then I try to bring them up to you and just try to make sure it's clear so that everyone understands.
Yeah,
But
no worries.
awesome presentation, sir.
All right, so non-continuous load, 60 amps, 100% gives you 60 amps. We had 100 amps of continuous load. Take that at 125%, gives me 125 amps added up. You got a total calculated lighting load of 185 amps. Okay, that's that's pretty simple to do. All right, and here we've got you some more loads. We've got 70 amp of non-continuous, 90 amps of continuous. You should be able to calculate that. We set the percentages in there and calculate your total load for next week. All right. Now, let's look at it from another point here. Now, this is where you're going to get into your general purpose lighting load. Okay. We're just not giving you a load here to calculate. Now, here we're going to ask you to do an office facility. Okay. Now, back when we were doing this, we used to go in and uh, we used to take and look at this and do this at 3.5. Well, what happened over time, of course, is we started doing things a little bit different. Okay. And this had to do with the energy code. All right. So they dropped this down. And if you go over and you look at your office, or let me tell you the table, go to table 220.12. And I think it's around page 74, 75 in your code book, somewhere in there. But if you go over and pick that table up and come down and you pick up an office and come straight across, it's going to tell you the volt amps per square foot is 1.3. Okay. So it's sort of like when we looked the other day when we were looking at the dwelling unit. I said, you look at 220.14J and it tell you to take it at 3 VA. Well, here's the same thing. We're just taking the square foot of the facility. This is going to be my full general purpose sliding load for an office facility. It says I can take it at 1.3 VA per square foot. So I take that 8,000 square foot, and that'll give me a general purpose sliding load of 10,400 VA. All right. Now, when you look at this one, this is interesting because look, I've got 6,000 square foot, but it's telling me I'm going to do a store. Okay. So you're going to come over and you're going to be looking for something different here. All right. And you're going to look at table 220.12 to figure out what the general purpose sliding load is here for calculating this. Now, one of the things we put a note in here, and I want to go back one because I want to show you here. You notice here, we didn't tell you anything here if it was continuous or non-continuous. But if you look at this slide here, we tell you if all that lighting load was going to be on all the time, now we're telling you that that's a continuous lighting load. So I would have to put 125% on this. Okay. And that's the note in the exercise problem. But since we're not telling you, we're just having you do the general purpose lighting load for now. Just go over, find your store. We like to refer to these are listed occupancies. Now, let's say that I was going to do a welder shop, for instance. If you look in table 220.12, there's no welder shop in there. So that means you'd have to calculate each one of these individually. And we'll look at that here in just a little bit. All right. Now, here's the exact same thing I was talking about. I'm looking at this. I'm going to do these individually here. All right. I've got 60 lighting balances. They're rated at 1.5 amps, 120 volt each, and they're used for 12 hours a day. Now, if I go look at Article 100 for continuous load, that's any load that operates for 3 hours or more. We definitely beat that. So now I need to figure out what my VA is going to be here. So I'm going to take those 60 units at 1.5 amps, gives me 90 amps. Then I'm going to take it, because it's a continuous use duty here, at 125%. That'll give me 112.5 amps. It's 120 volt circuits. Multiply it by that, and it'll tell you the lighting load for the occupancy is 13,500 VA. Okay? We're showing you different ways to calculate this. All right? So we've given you 3 different ways so far to look at applying this calculation. Here's one here. Look at all the lighting units here. We're showing you electric discharge lighting. We got 16 units at 180 VA each. Calculate that. 12 units at 150 VA each for incandescent lighting. Calculate it. Recessed luminaire, 10 units times 100 VA each. Calculate it. Then you get your total. What do you take it by? 125%. Pretty simple.
Yeah,
Okay?
I don't know. Looks like you're splicing inside a conduit body there. I don't know.
Nope, that's a box. All right. Now, let's look at show window lighting. Now we're going to look at 220.43A. And when you go over and you look at that section, it says, for show window lighting, a load of not less than 600 amperes linear meter or 200 volt amperes per linear foot. Well, it just told me there, for each one of those linear foot, I have to take it at what? 200 VA. So if I've got 80 foot, we'll do it for continuous and non-continuous. So just take the 80 foot times 200 VA, gives me 16,000 VA. Now, if it's continuous, just take that 16,000 VA at 125%, and that gives you 20,000 VA. Very simple. All you need to know is stay in Article 220 when you're doing these calculations to get your multipliers here. And for show window, it'll tell you to take it at 200 VA. All right. And here we've got 100 foot of continuous, 100 foot times what? 200 VA. Then if you got continuous, take it at what? 125%. This should be a very, very simple exercise problem. Now, let's look where I'm doing track lighting. And you're still in the same one, but you're going to be looking just at B instead of 220/43A. Now, when you look at track lighting, what does it tell you over there? It says when you have track lighting, and it'll tell this, it'll say another than, of course, dwelling units or guest rooms or guest suites of your hotels and motels. It says an additional load of 150 volt amperes shall be included for every 2 foot of lighting track. Okay. So if it's forever 2 foot, that means I got to divide that 80 foot by 2. Now, one of the things I want to point out, look right here, we did 80 foot here for show window. Okay. I just took it at 200 VA. Now I'm going to do this at 80 foot, but I'm going to divide it by 2, then multiply it by 150 VA. Okay.
Sure.
Because it says for what shall be included for every 2 foot of lighting track or fraction thereof. Okay. So basically just cut it in half. So it'd be 40 foot times 150 VA gives me 6,000 VA. And then if it was continuous use, then I just add the 125%, and that'll give you 7,500 VA. Okay.
Right.
Now,
hey, I had an interesting question come up about that.
Mm-hmm.
Where are your show window lighting receptacles required to be located, on the inside of the tenant finish or on the outside?
Well, they're on the inside.
That's kind of what I thought, but it doesn't really. Code doesn't really tell you.
Well, it's
Where
showing,
you
though,
provide
it's
them.
inside. It couldn't be on the outside.
I mean, it's kind of a.
That's where your lighting is. It's for the. Are you talking about for show window?
Yeah.
Yeah,
Doesn't
it has
really
to
say
be
which.
inside.
That's what I would say too.
Yeah, because it's specifically for showing stuff. That's why
Yeah.
you're getting that VA at 200 VA applied there, because you're inside that room. You're trying to light something up.
Yeah, and the
And
whole
you
thing is,
realize
if you
that.
put it outside, then everyone's just gonna steal all your signs.
Yeah. I mean, that's the way I'd look at it. I don't know why you put it out. I never even heard that.
Yeah, it was just a question that came in. One of the people.
Okay. Now, we got 30 foot of non-continuous. I'm not even going to put 125% on this. We're telling you it's non-continuous track lighting. So automatically, no, I have to have 100 VA for every 2 foot. So I'm going to divide that. That'll be 15 times 150 VA. Everybody should be able to do that pretty simple. Okay. Then the next load we're going to get into is low voltage lighting. And this is just simple. Whatever the full load current is that's being used for that low voltage lighting system, just take it at 100% or 125%. It's simple.
Right.
Okay. So non-continuous 50 amps. If it's continuous, take it at what? 125%. It does.
Right.
That's as easy as it's going to get for you right there, because you're going to be looking at the low voltage lighting system that is supplied by what? That isolation transformer. Okay.
Yeah, and one thing you guys have to keep in mind is that that's gonna operate at full load for more than 3 hours. So that's one of the things that they try to get you on the test, on the exam, that you have to watch out for, because if it doesn't operate at full load for, like, a lot of people think refrigerators a continuous load, but it's not, because it doesn't operate at full load for 3 hours or more.
Sure.
So just something for you guys to think about.
And then here you got 40 amps of continuous. 40 times what? 125%. That's simple. All right. Now, the next one we'll look at is where you get to your outside lighting loads. Okay. So we're going to determine here, we got 30 luminaires that are operating at continuous load, because more than likely was this parking lot, or it could be building lighting, anything like that. So we know it's going to be on for 3 hours or more. And we've got each one of these have a 75 VA ballast in each unit. And then I've got 10 luminaires operating as a non-continuous load, with each ballast having a rating of 75 VA. Okay. Same thing. You got your 75 VA times 30 for your continuous. If it's continuous, what I take it at 125%. That gives me 2,812.5 VA. Then I had 75 VA for 10 units that were non-continuous. That gives me 750 VA. Just total them up. You got 3,562.5 amps. More than likely, if I was doing this, if I go look at 220.5B, I would just round this up and I would go to 28 13 instead of 2,812.5. If it was point 0.4, I'd round down to 2,811. Okay.
Okay.
But just sort of show you, if somebody says, oh, that's 0.5, we just show you here and then tell you what we would do with that.
Nice.
Then you got your outside lighting load here. This is a simple one. We got 50 units at 120 volts each, and we tell you it's continuous operation. Just take the 50 units at 120 VA times 125%. You should be able to answer that. But the one thing I want to point out that I stayed consistent on is my continuous and non-continuous. Okay?
Yeah.
I'm figuring these loads. The only thing that you had to remember is if you're doing a full general lighting load based on the listed type unit, and I'm looking at table 220.12, it's taking it per VA per square foot. But if it's going to be one where all the lighting inside is going to, and outside you're just doing everything, and you take that whole unit inside and it's 8,000 square foot inside, and it's all going to be used continuous, then you need to make sure you put 125% on it. All right?
Nice. All right.
Now, the next one you get into is a sine load. All right? Now, what I want you to do, if you go over and you look at 220.14F, okay? Now, it's going to tell you there when you're doing a sign and outline lighting that you have to calculate at least one of those there for at least 1,200 VA, okay? Now, we've got 1,800 VA, but if they put on the test and they say 1,000 VA or 800, you have to kick it up to 1,200 VA, okay?
Right.
So you need to know, and if you notice, I'm still staying in Article 220, so you should be able to find this stuff when we're doing this calculation here. Now,
and just a little disclaimer: this is all 2020. We're gonna do 2023 separate. So for all you trying to follow, we're all doing this 2020 NEC.
Well, they just finished updating, and it's already being published. It's already published now, the Journeyman. But at the time, I didn't have all this done by 2023.
Okay.
So that's why we started on 2020. So
nice.
It's a continuous operating. It's for 3 hours or more. You just take it at 125%. I've already got the VA there. That gives me 2,250 VA. Okay. And then you look at your sign load here. What have I got? 1,200 VA. I know it has to be at least 1,200. It's continuous. Take it at 125%. There's your VA. All right. Then that's going to bring us into receptacle loads. Now, I want to point out right there what we just did. We went through, let's see, we did the general lighting load. We did 3 different versions of that. We did the show window load, the lighting track load, the low voltage lighting load, the outside lighting load, and the outside sign lighting load. So we did 6 loads for lighting with 3 versions on the general lighting load, depending on if you had a listed or unlisted occupancy. All right?
Yeah, and just a little kind of clarification too that I kind of learned about. One of the codes is like egress lighting, and a lot of times what they do is they'll do like a exit sign like as part of the emergency circuit, and that the discharge lighting, which the internal egress and the external egress is all calculated in with the emergency lighting, so that's all added in with your emergency circuit.
Okay. Now, let's look here at your receptacle loads. Now, this is very simple, and you're going to stay in the same thing. We just looked at 220.14F for the sign and outline load. Now, you're already on that page. If you go look right in the next column over there, near the top, I think, you'll see receptacle outlets. Okay? And when you're calculating these receptacle outlets here, it's going to tell you that you're going to calculate here at not less than 180 volt amps for each one. Okay, so when I look at this outlet, I've got 48 general purpose receptacle outlets, and I'm going to do it non-continuous and continuous. So I'm just going to take 48 of them at what? 180 VA. That gives me 8,640. And then I had the same thing, but I got them at continuous. I just add 125%, and that'll give me 10,800 VA. Okay? Now, one of the things you'll notice up to this point, I'm still doing the same calculation. I'm just pulling a few different type of values here. Okay? So, as an example, if I'm doing show window, I 200 VA. If I'm doing track lighting, I had to take the footage of the track lighting, divide it by 2, and multiply it by 150 VA. If I'm doing sign load, I had to take it at what? At least 1,200 VA. Here is your receptacle load, and you have to take it at least 180 VA. Okay?
Yeah, and this is where that myth comes from, where this oftentimes gets pushed into residential, where they say you can only have X amount of 15 amp circuits because they're all taken at 180 VA, but that's taking a commercial reference and applying it to residential is where that myth comes from.
Yeah, it doesn't work that way. And I think we did a podcast where I went in and showed how to do all that, and how some inspectors look at it and they limit so many outlets based on the circuit sizing. But if you actually look at a residential, it doesn't work that way.
We did.
And we did do it. I thought we did. I know I've taught it a bunch.
Oh, yeah.
All right.
Oh, yeah.
Same thing here.
I'm going to just start doing that every podcast. It's like, covered it.
You always give me all these crazy ass subjects. And I'm like, okay, yeah. So, all right. Now, this in here, we got 40 receptacles. Each receptacle is 180 VA. We're going to have you do the continuous and non-continuous. You should know just to multiply the number by 180, and if it's continuous, add 125%. Now, this is where we're going to look, and this is where you get over 10,000 VA. Okay, and we're going to be looking at table 220.40 in just a minute. But we're going to do a calculation here for 125 general purpose receptacle outlets for non-continuous operations. Okay, so you take the 125 receptacles at 180 VA, gives me 22,500 VA. Then if you go over and you look at table 220.44, and I think it's like on the bottom right-hand side of page 75, 76, 77, somewhere in there. But you go over, it'll tell you the first 10 kV or less at 100%. Anything over that, you take it 50%. Doesn't matter how much it is, but you can take the rest at 50%. So I'll take the first 10,000 at 100%, it's 10,000. Then I've had 12,500 left over from that 22,500 VA. Take that at 50%. That'll give me 6,255 or 6,250 VA. Multiply that together, gives me 16,250 VA. Okay. And then here we're going to do 150 receptacles non-continuous. Just remember, when you get over 10,000, take it at 50%. And each receptacle outlet has to be taken at 180 VA. Okay?
Hey, do you want to hear the 2026 answer on that one?
What do you mean?
50% of them will have to be on controlled. Like, dude, they're getting, like, this energy management's getting out of control right now. Like, they want all these receptacle loads to be controlled with, like, times they're occupying the building and stuff. Dude, it's out of control. It is.
Well, I will tell you, when they come out in July, I think it is, and everything comes out and what all failed and all that, and I can see everything, I will, at that point, I will start going through some of that, getting ready for the code change book for when the next cycle comes. Dad and I
Yep.
made a decision we're going to start this thing real early and have the majority of the stuff that went through, and then we'll go back and make whatever changes. So we'll have more time to detail through it more. And
Nice.
we're going to go ahead and get that portion of the book ready, and then see what other changes failed that look like they might come up pass, and we may do some illustrations, get those ready. And if they pass, great. If they don't, then we don't have to worry about it. We'll just
Well,
have it in the cooker for later.
congratulations. This is the first code change publications where you'll have my public inputs in there. So, congratulations.
You dog. I'm not even going to look at them. There's no telling what you put in there. Okay. Now, let's look at this. This is where you get to use a outlet assemblies that are used for cord and plug connected loads. And we're going to do two where you use them simultaneously and where they're not used simultaneously. All right. Now, when you get into this, you need to go look at H1 and H2. It'll be just right above your receptacle outlets, and it will say fixed multi-outlet assemblies. Okay. And what it tells you in one is where you get into non-simultaneous use. And it says each 5 foot or fraction thereof of each separate and continuous lead shall be considered as one outlet of not less than 180 volt amperes. Okay. And then when you go in and you look at 2, where you're using them simultaneously, it says where appliances are likely to be used simultaneously, each 1 foot or fraction thereof shall be considered as an outlet of not less than 180 volt amps. Okay, so if I'm using it simultaneous, each 1 foot, so that means you're going to take the 180 VA time whatever the length is. But if I'm looking at number 1, it says simultaneous each 5 foot or fraction thereof. That means I've got to divide it just like I did for my track lighting, divide it by 5. Okay,
Right.
the other one was dividing by 2. So in this one, I'll take for non-simultaneous use, I'll take the 100 foot, divide it by 5, multiply it by 180 VA. That gives me 3,600 VA for my non-simultaneous use. And then if it's simultaneous use, you just do it like a regular receptacle based on whatever the footage is. In this case, 100 foot times 180 VA gives me 18,000 VA for simultaneous use. Okay?
So, yeah, so in layman's terms, it's just basically like how many daughters do you have using how many cell phones?
Yeah, no kidding. Okay, now this is interesting because right here you got 200 foot. Same principles. I'm just, if it's non-simultaneous, divide by 5 and multiply by 180. If it's simultaneous use, you just multiply it by 180 VA based on whatever the footage is for that multi-outlet assembly. Okay? Now, got that taken care of. That takes care of your receptacle load. So now we've done 2 loads. Okay?
Yeah.
And so far, this hasn't been that hard because you're following a step-by-step procedure, and you've got a means in order to put it in order so you know how to apply the calculations. So once you get through those 2, then we're going to look at what type of special appliance loads do I have. Okay, now here's a basic one. This is where I have a 208 volt 3-phase, and we're not even telling you what type it is. It's just a 65 amp special appliance load that operates for 10 hours or more, and it's supplied by an individual branch circuit. Now, I'm going to tell you, this doesn't have an outlet. Okay? This is something we're going over and we're hardwiring. Okay? It's some special appliance, it's some piece of equipment. You know, you're just going over, you're making a termination. Okay?
Yeah.
So the first thing I need to do is I need to calculate this and just put it in VA form. Okay? Now, we did this when we first started all of this. We did just the basic calculations, and I showed you how to get everything in VA form. So just take your voltage. In this case, it's 3-phase, so I have to take it times 1.732 And we have a 208 volts. So that'll give me 360 volts, and then just multiply it by the amperage, and there's your VA of 23,400. You got your VA for the special appliance load. It's at continuous load here, so I have to take it at what? 125%. That'll give me
Why?
29,250 VA.
Why do they call it a special appliance? Because it doesn't. It connects to an individual branch circuit.
Because it's utilization equipment that's connected
Yeah.
strictly to an individual
Hey,
branch circuit. There's no free floating outlet there.
hey, I got a good one for you on EVSE.
Hmm.
Where's the outlet? Is the outlet at the end of the EVSE? Because the premises wiring ends at the EVSE, and the vehicle is the utilization equipment.
Now, the utilization equipment is the unit itself, and that's why they have all them special features and everything on it to protect people. And
Right.
some of those units come out and they tell you not to put GFCI protection upstream because they're already providing it on the load side, and they're using
True.
something that is other than a Class A.
True.
Okay.
I agree.
Now, this in here's just showing some type of appliance they're going to, and the load is 13,720 VA. I already gave you the VA. The one before I showed you how to get the VA if you didn't already have it. And we're telling you the VA, it's continuous. And since it's continuous, we take it at what? 125%. Okay. Now, if this was non continuous, just put the VA on there and you're done. All right. Now, let's look at uh, this one here. Here's a special appliance load, but it doesn't operate for 3 hours or more. It's operating at a period of 2.5 hours every 4 hours. So it never operates at a continuous load of 3 hours. So
Nice.
I'll just take the voltage here. It's 480 volt. It's a three phase. So I'll take it at 1.732. That gives me 831 volts. It's at 52 amps. Multiply it by 52 amps. There's your answer, 43,212. If it was
Nice.
continuous, I'd add 125%, but it's not. So your VA has been calculated for that special appliance load. We're using the
Nice.
same appliance load here. What, you don't even have to do anything. Your load's already given to you
Well,
right there.
well, apparently you got floppy nipples because you don't have to do anything. So you got floppy nipples in that illustration.
Sometimes. All right. Now, let's go over, and I want everybody to look at 220.56, which is going to refer you to table 220.56. And when you go over and look at that, they've got some demand factors here based on the equipment. Now, say if I had 5 pieces of cooking equipment here, I would take and be able to apply a demand factor of 70%. If I had 6 or more, I can take it at 65%. Okay? So I look at this here, and we're just making it easy for you. We got 10 units here at 208 volts, three-phase cooking units that are rated at 8 kW each. Okay? So you take 8 units times 10 gives me 80 kW. I want to put it in amperage form here. So I'm going to take that kW rating times 1,000, and then I'm going to multiply it by the voltage. Okay? We had a 208 volt three-phase system, 1.732 for the three-phase, gives me 360 volts. Divide that into it, gives you 222 amps. Then just come down and look at your table 220.56. I had 6 or more units. It says I can take it at 65%. That gives me 144.3 amps, and just multiply it back by 360 volts, and that'll give you a total demand load of 51,948 amps. And here's a good
So
here's a good one here. We're showing you where we got 2 microwaves, 3 boilers, we got 2 steamers, 3 fryers, 2 kettles, 4 pieces of cooking equipment, and we're telling you the total kitchen load is 82 kW. Now, if I look at table 220.56, I'm over 6. I can already tell you I'm way over 6. So I can take that 82 kW at what? 65%, and that'll give you
Yep.
your KVA rating. Okay?
Yeah,
What was
and
your
I just
question?
wanted to kind of explain to people that anytime you see demand factor, that means that you don't have to calculate 100%. Like when you're looking at some of these panels, I mean, there's like say 300 amp breakers in these panels, and it's a 400 amp panel. How can you do that? Based on that demand factor. That not all that stuff's gonna be running at the same time.
That's true. And sometimes they put a 400 amp panel board there for future use. And
Yeah,
then they'll come in and change that breaker out. All right.
yeah,
Now,
100%.
right there, we've done 3 loads. Okay, we went through a lot of lighting loads. We went through receptacle loads. Then we went through special appliance loads. Now you're looking at your compressor loads. Okay, so I've got 6 compressors here rated at 26.5 each, and they're connected to a 408-volt 3-phase supply. So I'm gonna get it in VA form. Now, looking at this, I'm going to do all my motors here at 100%. Now, why am I going to do that? Because when I get to the end in my 7th calculation, I'm going to take between my refrigeration motors and everything else, and whichever is the largest motor load is going to be the one that gets the additional 25% applied to it. Okay,
True.
so this keeps you from getting screwed up. Just do everything at 100% on these compressors and motors. So I've got 6 of them here. I want to put it in VA form. So I'm going to take the 26.5 amps times 60, then multiply it by 831 volts. That'll give me 132,129 VA. Okay. Same thing here. I've got 2 different type compressors here. I got a 35 and 45 amp. I'm going to take it at what? 100%. Both of
Yeah.
them will be done at 100%. Just remember here, I've got a 480 volt 3-phase, so I'm going to take that 35 amps time what? 831 volts. And that'll give me my VA. Once you get all your VAs, take them at 100%, total it up, and there's your compressor load. Now we're down 4 loads. Now we're going to the 5th load. Here's my motors. All my motors, what am I going to take them at again? 100%. Okay,
Yep.
we're not doing 125 on any of these yet. So I've got a group of motors, 40 volt 3-phase. I got a 30, 20, and 15 horsepower. Now, we done this before. I said for 3-phase, you go over and look at 430.6A1. That's where you're going to go, and it's going to talk about table values. And it says anytime you're sizing your conductors and overcurrent device, to use one of the tables in 430.247 through 250. In this case, we got a 3-phase. So go over and look at table 430.250. You pick up a 30 horsepower at 480 volts, come down. It's going to tell you it's good at 40 amps. A 20 horsepower is good at 27 amps, and a 15 horsepower is good at 21 amps. Then I'm just going to take every one of those, drop down, and I'm just going to multiply each one of those amperages by the voltage at 3-phase for 8. That'll give me 831 volts, and it's going to give me for the 30 horsepower motor 33,240 volts, for the 20 horsepower 22,437, and for the 15 horsepower 17,451. Add those up, and your total load for the motors is 73,128 VA. Okay.
Hey, I have a question about that.
Mm-hmm.
So, let's just say you decide that you don't have 3-phase for the 21 amp motor, and you decide to power it with 480 volt single phase, and then you provide let's just say it's a 15 horsepower motor. We decide we're gonna put that one at a 30 horsepower drive and power it with 480 volt single phase. Is that a different calculation, or is it the
Sure, you
same?
just take it at 480 times 21
Okay.
to get your VA.
Okay. Gotcha.
If it was a
Right on.
120 volt motor, say it's 21 amps, you take 120 volts times 21, and that'll
So
give you
the
your VA.
rating the rating of the freak drive changes, but the calculation doesn't.
That's right.
All right, got you.
Okay.
Okay.
And here's 4 motors. We got a 10, 20, 25, and 30 horse. It's still 3-phase 460. Go to table 430.250, get all your amperages, come over, take them at 100%, and then at the end of it, multiply them all by 831 volts, and that'll give you your total motor load. Okay? And that, so far, that's 5 loads, right?
Yep.
All right. So now we're looking at what is left after that. The only thing that's left is what is largest between the heating and air conditioning load. Well, I can look at this. I've got a 30 kW heating unit and a 32.5 amp air conditioner unit. Well, it's 208 volt 3-phase, so I'll take the 32.5 amps for the AC load times 360 volts. That'll give me 11,700. It's smaller than the 30,000, so we drop that load. And the heating load is my largest non-coincident load, so that'll go into the calculation. Okay?
Gotcha.
And then you've got it here. I can already tell you, looking at this, you got 5.5 kW and 10 kW. 10 kW is going to be your largest load. You'll drop the 5.5 kW for the AC unit. And then that brings me to my last one, is the largest motor load. Okay?
Right.
So we're giving you from the loads that you would get this from. Load 4, 5, and 6. You had an AC unit at 30 amps. Their largest motor load that we had in the calculations we just did was 40 amps, and the compressor was 35 amps. It's simple. You got 40 amps here, take it at 125%, and then multiply it by whatever the voltage of the system is. Say it's 480. 3-phase, you take that 40 amps times 831 volts and put it in VA form. Okay?
Nice.
And then here we're showing you all the different loads you could look at here and which one of those is the largest. That's what you would go. So you would need to go over, and I'm not going to tell you this right off the bat. I know which one it is because I've already done it. But you've got your 10, 20, and 25 horsepower, 460 volt 3-phase. Okay? So you're going to look at that, and you're going to see if any of those amperages are larger than the 45 amp that's given in load 4. And then take that at 125%.
So I have a kind of a stupid question. So I encourage anyone in the chat to ask stupid questions at any time because I don't want to be the only one that James humiliates. But so basically, if you have like a combined load of like say all these EBSE chargers, is that done? Is that addressed at all in commercial calculations?
Yeah, it will be when we come out with the 2023 version. We'll do it for residential, and we will do it for commercial, and we'll do probably like maybe 10 units there and give them their VA rating because it comes as an assembly, and then that'll be calculated separately. And then we'll reference the minimum that it can be also.
Gotcha. Okay, cool. Right on. Thank you, sir.
Yeah, and that's what I was saying earlier when like we did the previously we done the dwelling units, and I said you had 6 loads. Well, when we do dwelling units, it'll be 7 loads we'll do. And then when you get into commercial, instead of 7, now it'll jump up to 8 loads that we do.
Gotcha. Okay, cool. Now that's good information.
Now, this is one that has been brought up before. People have asked questions, and this is where you're adding to an existing service. Okay, just sort of show everybody how to do this. And this is more for one that'll be on the Masters. So people that won't take the Masters, pay attention. So they could ask you a question similar to this. Can a load of 15.1 kVA, continuous and non-continuous loads, be added to an existing service with 400 kc mil THW copper conductors having a maximum metered demand load of 78.4 amps? Okay? So when you go over and you look at 220.87, this is what it's going to tell you. And the heading will be determining existing loads. So when you go in there, it's going to tell you that the calculation of a feeder or service load for existing installations shall be permitted to use the actual maximum demand to determine the existing load under all the following conditions. And look what it says here. The maximum demand data that is available for a 1 year period. Okay? Now, another thing it'll tell you too, the maximum demand at 125% plus the new load does not exceed the capacity of the feeder or rating of the service. Okay? So let's look at the maximum demand. It tells me I have to take that maximum demand, which is 78.4 at 125% into 20.872, which will give me 98 kVA. Then I'm going to add the 15.1 kV to that. That's going to give me 113.1. So now I just need to determine if the conductor is large enough. So let's go over and look at table 310.16. Now, when you go over and you pick up table 310.16 and you pick up 400 kc mil, it's going to tell you we got a THW, which is listed in the 75 C column, of 335 amps. Okay? So let's take and put it in VA form to see if I exceed that. So I'm going to take that 113.1 kVA times 1,000. Basically, it's going to give you 113,100 VA. Then I had a 208 volt three-phase service here. I'm going to divide 360 into it, and that's going to give me 314 amps, which is less than the 335 amps for the 400 kc mil. Therefore, that 15.1 kVA load can be added to that service without having to upgrade the service and components.
Nice. All right.
And then this in here will give you where you're adding a new panel board load of 102 amps. And we're showing you here that it was recorded at 208 amps for a period over 1 year. And I've got 500 kc mil conductors. Just do the same calculation that we just performed, and you'll be able to determine if you can add that to it. That is a master question. So hopefully,
nice.
Matter of fact,